So let's take some notes. This is really Unit 4, I suppose, on rates, ratios, and proportions. A couple definitions first. What is a ratio? That's a comparison between two quantities. We can write it like this, something like 2 to 3. We can write it as 2:3, or we can write it as a fraction, 2/3. We're comparing these two quantities in three different ways. Another definition, proportion, that's when two ratios are set equal to each other. So 2/3 is equal to 4/6, for example. You'll notice a couple of things. You can double the top, 2 times 2, and get 4. And if you double the bottom 2, 3 times 2, you'll get 6. That's because these are proportional. That is why that works. Sometimes we'll encounter these same sort of problems, but instead of all the numbers, we'll have some missing. Like there's an x here underneath the 4. Just like we did in the last unit, we can cross multiply. 2 times x is equal to 3 times 4, which is 12. And if we divide by 2, we get that x is equal to 6. So if you plug that back in, what you have found is what value of x makes this proportional. Remember that you can only cross multiply like this when you have two fractions that are equal to each other. A couple more definitions. For a rate, that's the ratio of two quantities with different units. So let's say we had something like $30 for 10 minutes. That's a rate. As long as they have different units, like here it's dollars and minutes, it works. Then there's something called a unit rate. So if that was the amount of money for 10 minutes, how much for 1 minute? In other words, the bottom number, or the second quantity, if you will, has to be 1. So here that's going to be $3 per 1 minute. And that's the unit rate. And we can use those unit rates as conversion factors. So let's say we're talking about 1 foot, and we want to multiply this by a conversion factor of 12 inches per 1 foot. Well, it turns out that foot and foot cancel out, and the only unit left is inches, and we can multiply straight across. Let's look at a few problems, some examples. Here we have a proportion, 3 is to 9 as 5 is to m. So you might notice that 3 times 3 is 9. So could you do 5 times 3 and get an answer that m is equal to 15? Yes, you could. That totally works. You could also cross multiply. 3m is equal to 45. And if you divide by 3, you also get 15. It's only this easy, though, when you have the most basic fractions. When you start getting into quantities and expressions, then it gets a little bit more challenging, and I think cross multiplying really helps. So how do you cross multiply when you have something like y minus 3? Well, just like you would with distributing. And 6 times 7 is 42. So 2 times the quantity y, and 2 times negative 3 gives me 2y minus 6 is equal to 42. And we can solve this by adding 6 to both sides. So 2y is equal to 48. If we divide both sides by 2, we get that y is equal to 24. So if we were to plug that back in, what will you notice? Well, these are proportional. Think about it this way. 2 times 3 gives me 6. 7 times 3 gives me 21. What's 24 minus 3? 21. What about when we have two variables? Can we still cross multiply? It turns out we can. This gives me a squared, because a times a is a squared. And 2 times 8 is 16. To get a by itself here, we have to take the square root of both sides. And this tells me that a is equal to 4. All right, let's look at a few more examples. The ratio of the number of bones in the human skull to the ear is 11 to 3. There are 22 bones in the skull. How many bones are in the ear? So we have 22 bones, and we are multiplying by a ratio. In order to cancel out the, I guess I should say 22 in the skull. In order to cancel out skull, I need to have this ratio set up so that this number for skull is on the bottom. So I'm going to write that like this, times 3 ear over 11 skull. And I can multiply this by its conversion factor. So 22 times 3 is 66, divided by 11 is equal to 6. So there's the answer. There are 6 bones in the ear for every 22 bones in the skull. We take that ratio, and really all we did is double it. 11 times 2 gave us 22. 3 times 2 gave us 6. But representing it this way will really help us when we start tackling some more complex problems. Let's look at another one. The ratio of games won to the games lost is 3 to 2. So won is 3, lost is 2. I'm going to write it as a fraction. If the team won 18 games, how many did they lose? I'll put X for the number of losses. And as long as you keep the 1 on top, like the number of games won, and the number of games lost on bottom, you can't really go wrong. I like to cross multiply. 3x is equal to 36. X is then equal to 12 because you divide by 3. A cook flipped a pancake 416 times in 120 seconds to set the world record. Find the unit rate in flips per second. So if we have 416 flips per 120 seconds, if we're trying to find a unit rate, we are trying to change the bottom number to be 1. So what if I divide by 120 on the top and the bottom? On the bottom, I surely get 1. And on the top, what is 416 divided by 120? 416 divided by 120 is 3.46 repeating. And that is flips per 1 second. Number 7. A cheetah can run at a rate of 60 miles per hour in short bursts. Use a conversion factor to find the speed in feet per minute. So how many feet are in a mile? Is that 5,280? That sounds right. So 60 miles per 1 hour. And I'm going to convert from miles to feet. And I want to cancel out miles. So I'm going to put 1 mile on the bottom. And that means that 5,280 feet goes on top. And I also change from hours to minutes. Since hour is on the bottom over here, I'm going to put it on the top here and write it as 1 hour. And how many minutes are in 1 hour? That's 60 minutes. So notice what happens. Hour on top and hour on bottom goes away. And over here I have mile on top and mile on bottom goes away. And my final unit will end up being feet per minute, which is what I want, feet per minute. So I can just multiply straight across 60 times 5,280, and then I divide by 60. Since I'm taking 60 divided by 60, I'm just going to write the answer, 5,280 feet per minute. Number 8. A certain laser printer can print 12 pages per minute. Determine this printer's output in pages per day. So 12 pages per 1 minute. And I'm converting from minutes to days. So I'm going to multiply this by a couple of conversion factors. 60 minutes are in 1 hour. And 24 hours are in 1 day. I'm carefully lining this up so that I have minutes and minutes that go away, 1 on top, 1 on bottom, hour and hour that go away, 1 on top, 1 on bottom, and I'm left with pages per day. So I just multiply straight across, 12 times 60 times 24, 12 times 60 times 24, and that is 17,280. And that is the pages per day. Next up, the largest single rough diamond ever found, the Cullinan diamond, weighed 3,106 carats. 1 carat is equivalent to the mass of 0.20 grams. What is the mass of this diamond in milligrams? What is the weight in pounds? And they give us a couple of different conversions here. So we have 3,106 carats per 1 diamond. You don't really have to put per 1 diamond, but why not? Just makes it fit. And I know I'm converting carats, so they told me that a carat is equal to 0.2 grams. So I will put carat down here and 0.20 grams on top. And they want to know about milligrams. So 1 gram is equal to 1 milligram. What? That doesn't look right. Isn't it like 10 grams or 1,000 grams? Yes, 1 gram is equal to 1,000 milligrams, by the way. So I'm not sure what's going on with those notes, but that's okay. Blame your teacher. They made a mistake. I guess that's me. So 1 gram is 1,000 milligrams. This is one way to find how many milligrams are in this diamond. You can multiply straight across. So if you take 3,106 and you multiply by 0.2, and then you multiply by 1,000, you get 621,200 milligrams for the diamond. And if you wanted to do that in terms of pounds, well, 1 pound is 454 grams. So I think I would back it up to here and write 1 gram on the bottom. Well, not 1 gram. 454 grams on the bottom and 1 pound on the top. And this way, grams cancel out, carats cancel out, and I can figure this out. So now I'm going to take 3,106, I'm going to multiply that by 0.2, and then I'm going to divide by 454. And the answer is 1.36828,194 pounds. So if you can measure your diamond in pounds, you're doing good. Those are all the notes on the first section about rates. Nope, actually there's 2 more. A contractor has a blueprint for a house and its scale is 1 inch per 3 feet. If the blueprint is 6.5 inches long, how long is the actual wall? So we'll write blueprint on top and wall on bottom. And I know that the scale is 1 inch per 3 feet. So the blueprint is 1 inch and the actual house has 3 feet. I'm going to set that equal to 6.5 inches of a blueprint and x feet for the actual wall. So I can cross multiply here, and I get that x is equal to whatever 6.5 times 3 is, 19.5. I just cross multiplied. Next up, one wall of the house will be 12 feet long when built. How long is the wall on the blueprint? So I do the same thing. 1 inch per 3 feet is equal to, but now I'm going to put 12 feet on bottom. And I could cross multiply, but I'm just noticing, how do you get from 3 to 12? You multiply by 4. So I could just jump straight to the answer. I could write x and cross multiply, or I could just say 4 inches for 12 feet.